So in this video we are talking about a branch line coupler and a hybrid ring coupler, two different kinds of couplers or power splitters or dividers which are used to divide the power with varying degree of phase shifts as the output. So we are trying to measure S21. In this case we have set the frequency as 2950 megahertz to 3050 megahertz in 21 steps, which results in a faster refresh time of the display. We're trying to measure S21. That means that the port number 2 on the VNA is the receiver and port number 1 is the transmitter. We're using our standard calibration file and we have set the display to roll continuously. We are trying to measure gain versus frequency and phase versus frequency. So we have set the S21 in dB here and S21 in phase here. Let's try to measure a hybrid ring coupler. As you can see, in this hybrid ring coupler we use port number 1 to give the signal. We can see that this port number 2 is isolated. So as we can see that it results in two equal power divisions at port number 3 and at port number 4. The ports result in equal power division and varying degrees of phase by 180 degrees. So we're trying to measure. All the unused ports are deemed to be terminated in 50 ohms. So we are measuring a hybrid ring coupler at 3 gigahertz. We can see that it has resulted in a S21 of about 3.4 dB and the phase is roughly minus 3.4 degrees at port number 4. Now we replace port number 4 with port number 3. And as usual, the unused port is to be terminated in 50 ohms. Now in this case we see that the power has split to minus 3.5 dB, which was 3.4 for the other port. That means the power has split equally in two parts, while the phase is currently minus 161.5 degrees, which was minus 4 degrees there. So we have a phase difference of about 165 degrees. We expected it to be about 180 degrees for a hybrid ring coupler. Now we try to measure the quadrature hybrid. Again, for the quadrature hybrid, we connect port number 1 of the VNA to the port number 1 of the quadrature hybrid. The port number 4 is the isolate port and the two equal power splits are available at port number 2 and port number 3. These two power splits are separated by a phase of 90 degrees, as we will see. So we connect the port 2 of the VNA here and we connect the unused port into a 50 ohms termination. On the display we see that the S21 is minus 3.3 dBs while the phase is 110 degrees. When I move the port number 2 to terminal number 3 on the quadrature hybrid coupler, so we can see that this port S21 is minus 3.18 dB. That means the power has split equally in port number 2 and port number 3, while the phase is right now 23 degrees, which was 110 degrees in the previous port. So we have a phase difference of approximately 90 degrees between port number 2 and port number 3. So this completes our lesson about a hybrid ring coupler and a quadrature hybrid.